The last thing that we're going to talk about with respect to arrays is this concept called multi-dimensional arrays. So, what do I mean by that? Well, we've been working with 1D, one-dimensional arrays already. A 1D array is just a contiguous sequence of stuff, right? So we have one row effectively with some data in it. Okay? But a 2D array, as you might guess, kind of looks like a matrix or even like a spreadsheet. That's how I first learned how to think about 2D arrays. So, for example, we might have a 2D array with some values in it, like 2, 5, 7, 11, 10, 12, 19, 79. Put commas after those. 4, 3, 8, 68. Okay? So this is a two-dimensional array with 3 rows and 4 columns. And hopefully you can kind of see that, right? So these are the rows, and then these are the columns, right? So again, if you've ever worked with Excel or Google Sheets or anything like that, it's the exact same thing. We have rows of data, then we have columns of data. Okay? But the interesting thing about 2D arrays is that they are just arrays of arrays. And why can you see that? Well, you just think about a 2D array with its elements being arrays themselves, right? So each row corresponds to a separate one-dimensional array. Okay? So the question is, how do we create a 2D array? Well, we created a 1D array by doing something like int, open bracket, a equals new, int, and then 5, let's say. Okay? A 2D array is really difficult, okay? We use 2 sets of brackets for a 2D array. Okay? Really hard. B equals new int. And then we have to pass 2 values. So we're going to have 2 sets of brackets where the first value that we put here is the number of rows, and then this is the number of columns. Okay, so if we're trying to recreate this two-dimensional array up here, we're going to pass in what? We're going to pass in 3 for the number of rows, and then 4 for the number of columns. Okay, so now let's redraw out this array, but well, maybe we don't need to redraw it. Actually, yeah, I'll redraw it. So you may wonder, well, how do we access an arbitrary element of a 2D array? Well, let's rewrite the values first. So we have 2, 5, 7, 11, 10, 12, 19, 79, 4, 3, 8, 68. So when we're thinking about arrays, so let's say that this is our array B, we think of them in terms of accessing a row and then accessing a column. And typically, the value I represents the row and J represents the column. So let's enumerate these values. So we have row 0, row 1, row 2, and then we have column 0, column 1, column 2, column 3. Okay? And if we want to access let's say we want to access row 2. Okay? To get the to get the third row at index 2, we're going to do B at 2. So now that gets us access to this array right here. Okay? Now remember, I said that a 2D array is just an array of arrays. So now this thing is an array. So how do we access its elements? Well, it's very simple. We just do B at 2 at, and then let's say we want to access this value right here. Let's say we want to get the 3. Okay, we're going to do b at 2, 1. So b at row 2, column 1. That's the way to read this. Okay, so that shouldn't be too hard to understand, I think. So the question is, well, how do we get so like, if we want to get the number of elements of a 1D array, we'll do something like a dot length. Okay, so if we want to get the number of rows of a 2D array, we're going to do the same thing. We're going to do b dot length. Why? Because again, this is an array of arrays. So we want to say the number of rows corresponds to how many arrays are in this 2D array. Okay? Now, how do we get the number of columns? Well, the number of columns is just how many elements are in any one of these particular arrays, right? And in Java, arrays cannot be what's called ragged. Sometimes jagged is also, I think jagged is the more common term. But essentially it means that all arrays of a 2D array, all 1D arrays of a 2D array must be the same size. So for example, we can't have one row with only 2 elements and then one row with 3 elements and one row with 4 elements. Now, it's certainly possible that these entries are just like 0, but they have to exist. Like, you can't say, I want to create a 2D array where the first row has 4 elements, the second row has 2 elements, the second row has 3 elements. You can't do that in Java. So the way to do that is, well, remember that we can just get one of the arrays, it doesn't matter which one, so like b at I, and then get its length. Because remember, for the 4th time now, this is just an array. So we can get the number of elements of this. And that corresponds to, if you're looking at the picture correctly, that corresponds to how many columns there are. So we're going to do b at I dot length, where I is any value between 0 and b dot length. Okay, so I is any is either 0, 1, or 2, right? So we're getting any of the rows. It doesn't matter which one, because again, they're all the same. So we are we're just getting one of those, and usually people will just do b at 0. It doesn't matter. B at 0 is the most common thing you'll see, because in a 2D array there must be at least one row. Like you can't have a 2D array with 0 rows and 4 columns, because, well, that's just a 1D array. So Java won't let you do that. Okay, so let's so that is that's 2D arrays. And there's one thing I want to talk about first before we actually design a method in the next video, and that's how to traverse over a 2D array of values. So again, let's draw another small array. So like, let's say we have the values a, b, c, d, e, f, g, h, i, j, k, l, m, n, o, p, q, r, s, t. So this is a 5 by 4 array. This is a 5 row by 4 column. Sorry, this is wrong. This is a 4 by 5. This is a 4 by 5 array. So we have 4 rows, 5 columns. Okay. Now the question is, what if we're trying to process a 2D array? And we'll do that in the next video. But there's 2 ways. Well, there's more than 2, but there's generally 2 paradigms that people will use when traversing a 2D array. The first is by what's called row major order. So what does that mean? So this means that we are going to traverse over the rows and through the columns. So what that means is we're going to go from left to right and then bounce back to the far left. So we'll go from A to B to C to D to E, and then to F to G to H to I to J, and then to K to L to M to N to O, and then P to Q to R to S to T. Okay, so that's row major order because we're traversing over each row and through the columns. Okay, and there's also what's called column major order. Major order. And as you may expect, this is just the reverse. It's over the columns and then through the rows. Okay? So, as you might expect, that's like we're doing A, F, K, P, and then B, G, L, Q, C, H, M, R, D, I, N, S, E, J, O, T. Okay? So it's really like there's a zigzag here between each one. And then for the row major, it's like we're zigzagging this way. Okay? So sometimes the order doesn't matter. And in fact, you can even traverse in reverse row major order or reverse column major order. So you can go from right to left or bottom to top. It doesn't matter, okay? Well, it matters in the context of the problem that you're working with. So in general, it won't matter, but you really have to consider what your data looks like and whether your operations would be impacted by traversing in a different order, okay? So I believe for most of the examples that we give in this class and in the book, the order doesn't matter, okay? But if you're working with like really large matrices or things like that, then it may be advantageous to go in a different order. Okay. So actually, there is one instance where traversing differently matters, but that's really only that will only come up at the end of the class, at the end of the semester. Okay. So in the next video, we'll talk about how to use a 2D array in a method.